I'm Anil Kumar. Let me first thank all my subscribers for taking keen interest and posting excellent questions. It seems many of them want to understand how to solve quadratic equations by completing squares. Normally we don't do it. We either use factoring or we use quadratic formula, right? So the strategies which should be adopted are these two most of the time. Either you factor to solve or use quadratic formula, right? Let's be clear about it. But when do you complete squares? You complete squares whenever the questions are asking about maximum minimum, right? So whenever the question is asking about maximum minimum or even graph, then vertex form is what is required, and in such cases we use completing squares, right? Not for really solving quadratic equations like what we are considering now. But if that is the condition and you have to solve it using completing the squares, I'd like you to have patience, go through my videos. I'll take all these examples one by one. That should cover everything you need to know. So the idea is to write your quadratic equation in this form: 2x minus 3 whole square equals to something, right? So normally you're given in standard form. You have to complete squares to get to this form, which is shown in A. So in this particular part, to begin with, I already have a completed square, and I'll show you how to solve that portion, and in later half we'll take up all these other examples, right? I just added few more. Okay, so let's do the first one, which is 2x minus 3 whole square equals to 9. So first step will be square root. So we get 2x minus 3 equals to square root of 9. Now whenever you square root, you have to do plus and minus, right? Since you know minus 3 square is also 9 and plus 3 square is also 9. That is very critical. So we get 2x minus 3 equals to plus minus 3. That is square root of 9 plus minus 3. Now you can add 3 both the sides. So we get 2x equals to 3 plus minus 3. So we added 3 on both the sides. So that gives you two answers. So either we get 3 plus 3, which is 6, or we get 3 minus 3, which is 0. Do you see that? So x will be equals to 6 divided by 2 or 0 divided by 2, and we get x as equals to 3 or 0. 0 is a valid answer, and therefore you should not ignore it, right? It is a valid answer. Perfect. So that is how, after completing the square, we solve the equation as shown here. Now I'll go back to the last example here. We'll do all this after this one. The last example here is 3p squared minus 12. Now we have a missing term, and which happens to be coefficient of 0 for x term. So these cannot be completed. So here we do direct. There is no completing squares steps involved, and the solution for such equations is kind of simpler. We already have this kind of square. You can think it is p minus 0. Okay, so we could write this as 3p squared equals to 12, and that gives you p squared equals to 12 divided by 3, which is 4, and then p will be what? That gives you the answer, p equals to plus minus square root of 4, which is plus minus 2, right? So we get two solutions for this equation also, which is plus minus 2, right? So let me now continue with part B and C, and then we'll take D and E. Okay, so here is part B and C. So anyway, I just numbered them as A and B. So two more examples, and here actually we will see how to complete the square and solve quadratic equations. Okay, so it really begins from here. To complete the squares, remember one thing, that is what is a plus b whole square equals to? A plus b whole square is a square plus 2ab plus b square. So the idea is we have to get something like this to completely write as a plus b whole square, and let us see how we can do it. So first step involved will be take the constant to the other side. So we have x square plus 8x. Take away 15 from both sides, so that gives us minus 15. Do you see that? So this is going to be the first step. Second step is, see, this is center term. Center term is 2 times a and b. So this number is 2 times a is 1, b. So we have to get something half of this and square it. So what we do here is, we do half of 8, which is 4. So we add 4 square on both the sides. So this is very critical, and that is called complete squares, completing squares. So the steps involve half the coefficient. So square, so you add and subtract square of half of x coefficient. So x coefficient, make it half and square. So half of 8 is 4, square it, add both sides. So this is the most critical step which you have to follow. That is called completing squares. Now this makes this trinomial as a perfect square, and I can write this as x plus 4 whole square. So if you expand, you get x square plus 2ab. 2 times 4 is 8, 8x, and then 4 square, right? On the other side, 4 square is 16, correct? So I could write 16 minus 15 as 1. 4 square is 16. Now we'll square root both the sides. So we get x plus 4 equals to plus minus square root of 1. I have purposely taken very simple values in all my examples. Square root of 1 is 1, right? So we get x equals to minus 4 plus minus 1. So that gives us 2 answers for x. So either, let me write like this. So one of the answers is minus 4 minus 1. The other one is minus 4 plus 1. So we get x equals to minus 5. And the other one is minus 3. So these are the 2 solutions, correct? Which you could have got very easily by factoring. Product of 15, sum of 8, right? Product of 15, sum of 8. So what do you get here? If you factor, you get x plus 5 times x plus 3 equals to 0. The answer will be minus 5 and minus 3. And that is the reason why factoring is a better substitute than completing square. But anyway, if this is our restriction, we have to follow. That's the whole idea. So bear with me. Okay, so next one. So let's take 20 to the other side. So we'll do it a bit faster than last time. So we'll do it like this. Okay. Now half of 3. So this is complicated. First step is take 20 to the other side. Now here you will notice that coefficient of x is 2, not 1. So what we do here is multiply both sides by half. So we'll do half of this. So we'll do half of the whole thing. Do you understand? So first thing is make it kind of, let me write like this. 20, we have 2x squared plus 3x. Is it okay? And we'll do half of this times half of this. Is it okay? Divide by 2, the leading coefficient. That's the whole idea. And then rewrite. So we get x squared plus 3 over 2x equals to 10. Is it okay? So leading coefficient, divide by that. We need that to be 1. So that becomes easier. Okay, that's the whole idea. Now steps are similar. Half of 3 over 2 is to be squared and added. So we get x squared plus 3 over 2x plus 3 over 4 is half of 3 over 2. Square it, right? So 10 plus 3 over 4 whole square. Now that makes trinomial as a perfect square. So we get x plus 3 over 4 whole square on the left side. And here we get 10 plus 9 over 16, which 16 is the common denominator. And we get 169 in the numerator. Correct? Now we'll square root it. So we get x plus 3 over 4 equals to plus minus square root of 169 over 16. And that is plus minus 13 over 4, right? So don't get afraid of fractions. Now we can solve for x. X is equals to minus 3 over 4 plus minus 13 over 4, right? So we get two answers again as expected. So one is 13 take away, which is 10 over 4. The other one is minus 16 over 4. Is it okay? Now 10 over 4 is 5 over 2 and 16 over 4 is minus 4. So we get two solutions here. X equals to 5 over 2 or x is equals to minus 4, right? So I hope that's absolutely clear to you. So the steps involved are divide by the leading coefficient, then add both sides half of the coefficient of x square. That makes a perfect square, and then solve your equation as shown. Perfect. Now let's move on to the other two examples. Okay. So here we are. So these are actually application questions. You could have seen this in projectile motion something, right? So we'll solve these with completing squares. Here you see that the third term, the constant term, is 0 in this particular case, right? So remember the steps. The first step is divide by leading coefficient. Let me revise. So first step is divide by leading coefficient, right? So if it is 1, then you don't have to do this step. So I'll divide by minus 5. So what I'm doing here is that we do minus 1 over 5 both sides, right? 0 times minus 1 over 5, right? And what we have here is minus 5t squared plus 20t. So when you divide by minus 1 over 5, you get t squared minus 4t equal to 0. Correct? Now the second step is half of 4 is 2. So we will do t square minus 4t, add 2 square both sides. Perfect. These three trinomials make a perfect square, which will be t minus 2 whole square. And 2 square is 4. Now we are going to square root both sides. So we get t minus 2 equals to plus minus, don't forget this part, which is plus minus 2. So that gives you t as equal to, taking 2 to the right side, 2 plus minus 2. And that is two answers. Okay. So one is 2 plus 2, which is 4. The other one is 2 minus 2, which is 0. So that is our solution, right? The next one here is the last one of this video. We have half x squared minus 5x plus 8. So 8 has to be taken to the other side. So we get half x squared minus 5x equals to minus 8. Now we should multiply by 2 each term, right? So now we'll multiply, let me write times 2, right? Times 2, times 2. So when you multiply by 2, you get x squared minus 10x, right? And this is minus 16. Now we do half of 10, x squared minus 10x. Half of 10 is 5. So we'll add 5 square both sides. This becomes a perfect square, x minus 5. So the sign we are taking from here, do you see that? In previous cases, it was positive. So that is how all my examples are very different. Okay, so this is 25, right? So 25 take away 16 is 9. Then we get x minus 5 equals to plus minus square root of 9, which is plus minus 3. So x is equals to 5 plus minus 3. And that gives you two answers, right? Two answers. One is 5 plus 3, 8, 5 minus 3, 2. So these are the two solutions. And that is how we solve quadratic equations using completing squares. I hope that helps. Remember again, completing squares is not the best option. You could factor and solve it much faster. You could use quadratic formula for complicated values which cannot be factored. But if there is no option, you should do the way I have shown here. However, completing squares is excellent when you're trying to graph or when you're trying to find maximum minimum values, like optimization examples. So you have to follow these steps there in kind of different way, but these are the major steps to help you solve such questions. I hope that really helps. If you like, you can put some likes. Feel free to share your comments. Subscribe. Thank you and all the best.